All right, Algebra 2, we are on to our next target. It's in the quadratics unit. We're going to be looking at circles. Yes, you know about circles, right? We know what a circle looks like. But now what we're going to work on is a little something different. We're going to work on the equation of a circle. So if I'm looking at a coordinate plane, kind of like I am here, let's look and talk about the equation of the circle. So if I'm looking at circles, the obvious choice for shapes to start with to define this is obviously a right triangle. So I'm going to draw the right triangle here. Obviously a right triangle. We're going to talk about that. And one of the most common things that everybody seems to know about the right triangle is Pythagorean's theorem, which states if I've got a squared plus b squared equals c squared. In other words, if I take and square the two legs of this triangle, I get the square. If I add a squared and b squared together, I get the square of the hypotenuse. Okay, the square of the hypotenuse. Now, how are we going to use that? Well, I'm glad you asked. That's a really good question. What I'm going to do is start over here, just some random point over here. I'm going to call this the center of my circle. This is going to be a h, comma, k. Don't just ignore the numbers and the units for a second here. That's at h, comma, k. So it goes in the x direction. In the x direction, it goes h units. And in the y direction, it goes k units. So now I want to think about a point that's on the edge of the circle. And this is how it's on the edge of the circle here. I'm going to call this one x and y. X and y. So here's what I'm going to do. I'm going to draw the circle for you. Make a special circle here. It's going to be not great. And that's okay. That's okay. I'm going to do the best again. I'm just looking for the best you can do. Oh, yep. Let's try that again. Let's try that again. Again, you're just going to sketch. You're going to do the same thing I'm doing. Just sketch it out. Make it look nice. Make it look nice. Make it look as good as you can. Oh, wow. Maybe yours will be a little less egg-shaped. Okay, let's try it. Last time. Last time. Okay. Okay, so I've got my egg, I'm sorry, my circle. And so what I'm going to do is this. I am going to look at this point. So again, this is my point on the line. So I'm going to draw a line from my center to this random point on the line. And then I'm also going to look at this kind of right in here and this right in here. And this looks a lot like a right triangle because it is. Because it is a right triangle. Again, this is H and K right here. How can I make this triangle on the left look like that triangle on the right? Well, I need to know the length of this. I need to know the length of the two legs. Well, if I'm trying to think about the length of the legs here, if I want to know this length here from here to here, I know that that's the difference between going out. So this distance from here from the origin to there, that is x. That is x units. And then my other x distance is my h, right? Right in here. This is h. This goes to h. The difference between these 2 points, the distance there is x minus h. It's x minus h. That's like this a value, x minus h. That's that distance right there. In the same way, we can think about it in the y value. Well, the value to get to my y, that's y. And if I need to know this length here, I need to subtract the stuff that's below it, which was k. So the distance, this vertical distance here could be said to be y minus k. Y minus k. And then lastly here, to build this thing, what do we call the distance from the center to this circle, to the edge of the circle? Well, we call that a radius, right? We call that a radius, our r. Our radius is r. So if I take and apply these things, well, if this was C, this could go here. My B could go right where that is. My A could go right where that would be. And let's do that. So instead of A squared, I'm going to have x minus h squared. And then let's go with b, plus b. Well, b we called as y minus k squared. My c value, we're calling the radius, or r. This equals r squared. And so from right there, we just built circles, the equation of a circle from a triangle. See, I told you it would make sense and all work out. Told you it would all work out. Yeah, absolutely. This is the equation of a circle. X minus h squared plus y minus k squared equals r squared. Now, big thing, that whole h comma k, that's your center. So that's one of the things that we have to know in order to have the equation of. We need to know the center of the circle, which is at the point h comma k. And we also need to know the radius, which is r. We can do that. We have the technology. We have the know-how. We've done this. So let's just kind of start this out, right? Here's an example. It says, write the equation of the circle given the center and the radius. Example 1, the center is at 1 comma negative 4. My h and my k. My radius r is 2. Let's just go ahead and rewrite the formula here, or the equation of a circle. X minus h squared plus y minus k squared equals r squared. And here's the thing, we still want x and y to kind of be there because we want the equation for all the points on the circle. We just want to generalize this here. And so what we're going to do is this. We're going to replace h with 1 and k with negative 4 and radius r with 2. So we could actually have this be x minus 1 squared plus y minus negative 4 squared. Well, some of you eagle-eyed viewers out there will know that that's plus a positive, equals 2 squared, because that's r squared. I'm okay if you leave it as 2 squared. Big thing, don't do anything else. You could have also written this one, x minus 1 squared plus y plus 4 squared equals 4. I'm okay with either of those. But that's it. You are done. There's no more to this problem. You've just written the equation of a circle. That's all you got to do. Don't do any more than that. Just stop right there. Once you have the center and the radius, you're good to go. With that said, you try one. Example 2. So you're going to hit pause, write it out and give it a shot, and then come back. Okay, now that you are back, what we're going to end up with, we're going to treat our center once again as h comma k. Our radius is r. It's already right there. And we can rewrite it again. X minus h squared plus y minus k, that quantity, squared equals r squared. If we replace these things, we end up with x plus 3, because it's minus negative 3 squared, plus y minus 2 squared equals, you could say 5 squared, or you could have everything and have it equal to 25. Either way is correct. Either way is correct. I like leaving it as the 5 squared sometimes, because if I'm going to graph it, which you're going to have to, it's nice to know what the radius is and not the radius squared. Let's see what that next part looks like here. Again, that's it. Don't square anything out. Don't distribute, don't FOIL. That's literally it. Okay, let's look at our next part here. Write the equation of the circle given the center and a point on the circle. Interesting. Remember our equation, x minus h squared plus y minus k squared equals r squared. Well, what do we have this time? And what do we need? Like I said before, we need to have both the center and the radius. We have one but not the other, but we have the ability to do this. Write the equation of the circle given the center and a point on the circle. Well, we know the center, we still call this h and k. And what did I call the point on the circle? Just a generic x and y. Well, why do I want to call it that? What's the thing I don't know? What's the thing I don't know when I'm given this information? I don't know the radius. I need to know the center and radius. I don't know the radius. But guess what? If I plug something in for X and for H and Y and K, the only thing that I don't know is R. So let's do that. Let's do that. X minus H squared. So -3, because that's X minus -2 squared, plus Y, which is 2, minus 5, because that's K squared, equals R squared. Well, -3 plus 2 is, that's, so -1 squared plus -3 squared equals R squared. Well, remember, when you square a negative number, you get a positive. So -1 squared is 1, plus -3 squared is 9, equals R squared. So 10 equals R squared. Now, here's the thing. If you're just writing the equation, you can stop right there, because now you have R squared. But I know a lot of you are like, well, Mr. Brayman, what's the radius? That's a really good question. If the radius squared, if R squared is 10, if R squared equals 10, it seems to reason that I take the square root of both sides and I get R equals plus or minus the square root of 10. And I hope somebody out there is going, did he just say negative radius? Yeah. Does that make sense to you? It doesn't to me. It doesn't to me. When we're doing these, just like when we rejected the negative solution for some of the time stuff, we're rejecting the negative solution if we think about radius here. Now, again, all I need to write it was the R squared, but it's good to know the radius is the square root of 10, which is a little bit more than 3, right? Because 3 squared is 9 and 4 squared. Okay, so if I'm writing the equation, I'm going to go back and just give the general X and Y, keep my center in there, and then give my R squared. In other words, I'm going to end up with X minus H, which was -2, so X plus 2 squared, plus Y minus K, Y minus 5 squared equals R squared was 10. We can leave this as 10, or if you wanted to, you could have the square root of 10 squared, if this helps you out, because remember, that's like R squared. However you want to think about it. However you want to think about it. With that knowledge, go ahead and pause real quick. And then when we come back, you can check your answer. Okay, now that you're back, you can check your answer. Here's what we've done. We plugged in, we've got our H and our K. We've got our X and our Y for this one. We're trying to find R squared, or the radius, because we don't know it. We plug it into the formula. We get 9 minus 3 squared plus 4 minus -3 squared equals R squared. We end up with 85 being R squared. Right there, with all we're asked, we could put that right in. X minus 3 squared plus Y plus 3 squared equals 85. You could also do the radius. So you take the square root of both sides. Again, reject the negative solution in this case because we don't have a negative radius. And then we end up with X minus 3 squared plus Y plus 3 squared equals 85, or the square root of 85 squared. Remember that the square root of 85 squared, square roots and squares undo each other. Just saying the same thing. Okay. Now we got one more thing to look at. We got one more thing to look at here. It says, solve for the standard form of a circle given the general form of the circle. So what we've been working from is the standard form. Right now we're given the general form. We've got a whole bunch of x squared plus y squared minus 10x plus 6y plus 30 equals 0. Guess what we're going to do? Remember that quad 4 business when we completed the square? We're going to do that twice. We're going to complete the square twice to get it where we want it to be. It also asks us to identify the center and radius and graph the circle. So let's keep all those things in mind. What I'm going to do is I'm going to collect my x terms, my y terms, and then the constant that I'm going to push to the other side for now. What does that look like? I'm glad you asked. I'm going to do this, x squared minus 10x, and then I'm going to leave room to complete the square right there. This is gonna come from my x's. And then plus in my y squared, I've got y squared plus 6y plus something. This is gonna come from the y equals negative 30 plus the stuff from the x's plus the stuff from the y's when I complete the square twice. Well, let's complete the square in the x's. If I do that, I divide that the coefficient of the x value by 2. This becomes x minus 5 squared. And I square negative 5, I get 25. So I'm adding 25 to both sides from the x's. From the y's, I have to divide by 2, my coefficient of y, and I get y plus 3 squared. Then I square 3 to add 9 to both sides. And if I do that, now I've added the same things to both sides to make it balanced still. Negative 30 plus 25 plus 9. Well, 25 plus 9 is 34. Negative 30 plus 34 is just 4. I have now found the standard form. This is standard form right here. X minus h squared plus y minus k squared equals r squared. Now I need to find the center and the radius. My center is x minus h squared. Think of it like this. We're going to take x minus whatever value is in there. Or if you want to do it this way, the opposite of, if you see x minus 5, then the h value is 5. In this one, y minus or y plus 3, it's like y minus negative 3. My k value is negative 3. That is my center, is at 5, negative 3. Remember, 4, this x minus h squared plus y minus k squared equals r squared. R squared is 4. My radius then is 2. Radius is 2. So here's how I do this. I'm going to go up 2, left 2, down 2, and right 2, and then do the best I can at drawing a, oh, that's not even close. At drawing a circle. Is it great? Not a chance. Is it sketched? That's okay. But remember the steps we just did. We completed the square twice. We found the center by taking the opposites of these. We took the radius, we took the value over here and took the square, we took the value here and square rooted it to get our radius, and then we graphed it. With that said, go ahead and try your turn. All right, let's see if you went through the steps. First step is to collect your x terms and y terms. I like to put them in parentheses so I see what I'm working with. We complete the square twice. Well, we've also moved the constant to the other side. We've subtracted 12 from both sides. What we end up with is x plus 4 squared plus y plus 6, that quantity squared, equals 40. Because by completing the square on the x terms, it ends up x plus 4. 4 squared is 16. I add 16 to both sides. Y plus 6 squared, I square 6, I get 36. I add that to the other side. Negative 12 plus 16 plus 36 is 40. My center, again, the opposite is the h, the opposite is the k. So plus 4 makes my center negative 4 for the h. At y plus 6 ends up being negative 6 for the k. My center is at negative 4, negative 6. My radius is the square root of 40 because r squared is 40, but my radius is a square root of 40. Now that happens to be somewhere between 6 and 7, and I'm not super worried about it. I just know it's somewhere between 6 and 7. So when I draw my radius, I go a little more than 6 units in each direction, and I do my best at sketching. Now, some of you may have wanted to take this, the radius, the square root of 40. We know that's 4 times 10. So square root of 4 times square root of 10, or 2 root 10, that's okay. You don't have to do that in this case. So with that said, that takes care of circles. Now, we're going to have some practice to work on, and we'll see how that goes. Ask good questions. Take care. We'll talk to you soon.